Section 14.5, the law of cosines. As we're looking at the law of cosines, we're seeing that here we have our triangle. Once again, triangle ABC, where we have side A, side B, side C, opposite of this. Under law of cosines, this allows us to work with things in a different way. In the past, with law of sines, we need to know a side and an angle opposite. Where law of cosines happens, what if we know two sides and the angle in between? We don't know anything about the side opposite of an angle, but yet we only know one angle. So under law of cosines, we talk about a squared would equal b squared plus c squared minus 2bc cosine of angle A. And then this could be written for b squared or c squared, just changing out. So what we find is that the side squared equals the sum of the other two sides squared minus 2 times the product of these, and then the cosine of the angle in between those. One thing that we could consider on here and we start thinking about is a simple fact that if I were to want to solve for an angle, let's say I have three sides and now I want to find the angle of a triangle. Basically what we do is we have to subtract over, so we'd have a squared minus b squared minus c squared equals negative 2bc cosine of A. So then cosine of A we would divide over by a negative 2bc, in which then I'm going to distribute that negative through. So what it was when I divided over by this negative sign over here, it changed this to be negative and then positive because I took that negative and distributed in my numerator. Thus I had less negatives in my overall problem. So we see that if we have three sides, we can solve for that angle in here. Where this is found, once again, is on our formula sheet. There is a law of cosines right below the area one. If you notice in the law of cosines, we have our original ones right here. We have our three different style ones. And then we have this converse portion of this, where what happens if we know our sides and now we want to try to find the angle in between, or the angle of this. Basically what this kind of starts dealing with, it allows us to work with a little bit more exact of a triangle. Now some of the things we're thinking about with the cosine, remember in law of sines we had the ambiguous case where we couldn't tell between obtuse and acute. If we think about this, A is going to equal the cosine inverse of whatever is going on here. If you remember back, the cosine inverse was defined from 0 less than or equal to theta less than or equal to 180 degrees. So the cosine inverse does encompass what obtuse and acute triangles would be. So this one has no ambiguous case. So there is no ambiguous case in this portion of it. And that's one of the nice things about law of cosines, is it really defines down a little bit more definition into this. So if we start looking at how these problems work, we're going to start with number 8. Okay, on number 8, they give us triangle DEF, and then this would be side X is what we're trying to find. We're given 31.7, 35.2, and then they tell us this angle right here is 49 degrees. If we're considering this problem right here, we're asked to find the third side, given that we know two sides of a triangle, but we know the angle in between. So what we would do is we would state x squared equals 35.2 squared plus 31.7 squared minus 2 times 35.2, 31.7 cosine of 49 degrees. Kind of ran out of room here on my paper. But given this now, we'll state that x equals, we'll take the square root. Remember, we're taking the square root of this whole thing. So my suggestion to you is, if your calculator is capable, you could do this all at one time. but if you're not, you can bring answers in and down. You could figure out what this is and then take the square root. Given the calculator I have right here, I'm going to take the square root. We have 35.2 squared plus 31.7 squared minus 2 times 35.2 times 31.7 times then our cosine of 49 degrees. We do this and bam, we have our answer. 27, so now I'll go x equals 27.9. And we're done. We found that side. That easy. Law of cosines doesn't have all this other stuff that goes into it. It's just a basic equation operation. If we continue on and look at some next problem, what happens when we have to find the angle of this. So if we come here to problem number 10. Okay, on problem 10, they give us this triangle. In this triangle, they state this is 12, 14, 19, and they ask us to find the angle that is across from the side length of 14. So considering what is happening here, we have to decide what formula we're going to use. Now, we could substitute into the regular one and solve, or we could use our converse one. So basically what I'm talking about here is I could just substitute into here and go 14 squared equals this, or I can come down here and have everything inverse. So I will work this one both ways for you. Once again, the answer is going to be the same. So I can go 14 squared equals 12 squared plus 19 squared minus 2 times 12 times 19 cosine of x degrees. And then what we're going to find out is we're going to start simplifying this and basically solve for x. So if I get my calculator here, 14 squared is 196. So I have 196 equals 144 plus 19 squared is 361 minus 2, or let me just multiply that out. So if I take 2 times 12 times 19, that would be 456 cosine of x. So then when I subtract over these, I have 196, 196 minus 144 minus 361, which would be a negative 309, equals negative 456 cosine x degrees. Take this, now this would be 309 over 456 equals cosine of x degrees. So x would equal the cosine inverse of this. So if I take the cosine inverse of my 309 over 456, I hit equals and we get 47.3 degrees. Okay, so once again we're able to figure out what that degree angle would be in there. Now this would be starting with our original law of cosines. If we had wanted to, we could have used the converse to this. Okay, we could use one of these converse theorems right down here. So in this we would be looking at, so I'm just going to write this right here, we would be looking at cosine of x would equal. Now what we would do is we would have to realize that the side opposite of this is 14 is what my negative 1 is. So if you notice that right here I have cosine c equals, and then it's a minus c's over here. So my side opposite deals with this right here. So we would go 12 squared plus 19 squared minus 14 squared all over 2 times 12 times 19. If we're to think about this, we subtracted this over, then we divided by a negative product of this. So if I took that negative that would have been down here and distributed up here, that means that this would have been negative, and those would be positive then when I come over on this side. And then we could have just went x equals a cosine inverse of whatever this is. So rather than going through all these steps, we see that by having this converse theorem, we're really simplifying our work out. Now looking at one of our story problems we have in Law of Cosines, let's go to number 28. Okay, on number 28 here they talk about a softball diamond is a square that is 65 feet on the side. The pitcher's mound is 46 feet from home plate. How far is the pitcher's mound from third base? So we have a softball diamond. So those of you ladies out there that play softball realize that our softball diamond is truly a square that is on its side. So if I hold it a little bit like this, notice I have a nice square, but if I put it back, now there's our diamond shape. That would be a softball diamond. They gave us that, once again, a square would be right angles with 4 congruent sides, and we're given that we have 65 feet on each side. From here they talk about the pitcher's mound. So once again, the pitcher's mound is in a direct line from home plate to second base. So we'll just throw that pitcher's mound right here, and they state that this is 46 feet. Okay, so the pitcher's mound is 46 feet from right here. They then asked us, well, how far is the pitcher's mound to third base then? Well, some of the things that we know that this is 65 feet over here. So if I just kind of come down here and I look at what I have 65 right here, this is 46, and we know what this angle is right here. We know this angle right here is 45 degrees. Now, what we don't know is we don't know that this is a right triangle. Okay, so we're not given that we have a right triangle on here, but what we want to do is we want to try to find this missing side. So we'll go x, once again the distance right here, drawing that x back of my original picture. So x squared equals 46 squared plus 65 squared minus 2 times 46 times 65, cosine of 45 degrees. Okay, so x is going to equal, we're going to take the square root. Okay, now do realize that cosine of 45 degrees is a square root of 2 over 2. We should have that one memorized from our previous chapter. Once again, going on that unit circle, we shouldn't have to use any approximation for that part of it. But then we're going to be taking the square root of square root. So overall, we're going to have this approximation. So we're going to take the square root of 46 squared plus 65 squared minus 2 times 46 times 65 cosine of 45 degrees, and we get 45.96. Okay, so we see that x equals 45.96 feet. So really we're at 46.0 feet. Do realize it does look like this would be a right angle right here, but we are off just by a little bit. But once again, 0.04 of a foot is very small, so overall we could classify this as a right triangle. But do remember that this plate is not always at a right angle right here, giving this congruency in here. There are other issues that go into play here as we continue on and into other problems. Baseball is a very particular one that is not like softball.